In our first two examples, we will look at solving using linear equation methods. It is useful to think about the algebraic form of this equation before we solve the trig version of this equation. So when you see a trig function, let's think about that for a minute in terms of the algebra. So think about tangent theta as being just a variable like x. So 3x minus square root of 3 equals 0. The methods that you would use to solve this equation in algebra will be the same methods that we will use to get tangent theta by itself on one side of the equal sign. So the first thing that we're going to do is we're going to add square root of 3 to both sides. So we get 3 tangent theta is equal to positive square root of 3, and then over here we would divide then by 3, and that's what we're going to do here. We're going to divide by 3. So we get tangent theta is equal to the square root of 3 over 3. Now this would be our first goal, to get the trig function by itself on one side and the number on the other. So the next thing we want to know is what angle would give this trig function value. So we're looking for the quadrants where tangent would be positive. So we want to look in quadrants 1 and quadrants 3. So what reference angle family are we looking for? So remember that before we rationalized, if I was to unrationalize this, I would end up with 1 divided by the square root of 3. And remember that tangent is the y value divided by the x value. So I'm looking for points on my unit circle that if I did y divided by x, I would get 1 divided by the square root of 3. Well, the points that I have are all divided by 2, so let's write it in the actual form of those x and y values. So that would look like 1/2 divided by the square root of 3. So we're looking for points that have a y value of 1/2 and an x value of the square root of 3. So it looks like we're dealing with the 30-degree angle family. So that's our 30-degree angle here, and keep in mind that we're talking about that reference angle family. So when we go into quadrant 1, we have a reference angle of 30 degrees. Remember that reference angles start at the x-axis and then go up into the quadrant from the x-axis. So we have a 30-degree reference angle there, and then we're going to use that reference angle family and we're going to go 30 degrees also into quadrant 3. So we're looking at 210 degrees and 30 degrees. So the angle that has a tangent value of positive square root of 3 over 3, there are two angles that have that positive tangent value, and that would be 30 degrees in quadrant 1 and 210 degrees in quadrant 3. So we always want to make sure that we look in both quadrants where that trig function is positive. Now these are our two solutions over the interval 0 to 360 degrees. What if we were looking for all possible solutions? So not just the ones on the unit circle, but maybe I want to go around the circle twice or 3 times or 4 times. Well, we also want to give all possible solutions in terms of all coterminal solutions. So if I went around the circle again, let's say that I went all the way around again, and I hit and landed on this spot again. So I'll go around all the way around again. This angle, 30 degrees, is coterminal also to 390 degrees, for example. So there are several angles, all possible coterminal angles, that all have exactly that same positive tangent value. So when we're looking for all possible solutions, there's a couple of different ways that we can write this. Looking for all possible solutions, one way to do it is to take each angle and add multiples of 360. So we could say that to find all possible solutions, you could take 30 degrees and add 360 times integer multiples of n. So 1, 2, 3, 4, negative 1, negative 2, negative 3. So n is just any integer. So any integer multiples of 360 added or subtracted to 30 degrees would find all possible coterminal solutions to that angle 30 degrees. And we could also do the same thing for 210 degrees. So we take that angle and add all possible multiples, integer multiples of 360. So that would give all possible solutions that have that positive tangent value. Now, there is a more efficient way of writing this. If I look at these 2 points on my circle, so we look at the 2 points here on the unit circle, we notice that 30 degrees and 210 degrees are actually equally spaced around the circle. They are 180 degrees apart. So if I started at 30 degrees and I went 180 degrees in the positive direction, and then I did it again from 210 back to here, another 180 degrees, I could go from point to point to point. I could keep adding 180, and I keep finding all these coterminal solutions a little bit more efficiently just by adding 180 degrees over and over and over again. So another way that we can write these solutions, which this might be the solution that you would see in your book, is to take the smallest angle that we found on the unit circle, which would be 30 degrees, and add multiples of 180 to that angle, and then we would actually land on 210 and then back to 390. We would actually keep finding all those coterminal solutions in a little bit more efficient way. So here in our next example, we're going to solve once again using linear methods. So if you imagine sine x, if you think about that as being like, well, let's come over here. If I thought about that as being like a linear equation in algebra, that would look like, let's call 2 sine xy, so like 2y plus 3 equals 4. And remember, the first goal would be to get that trig function by itself, in other words, getting y by itself. So how would we accomplish that? Well, I would subtract 3 from both sides of the equation. So we would have 2 sine x equals 1, and then divide by the number that's multiplied times the front of that trig function. So sine x is equal to a positive 1/2. So we're looking for our angles on the unit circle from 0 to 2 pi, which means we're working in radians. So we're going to report our answers in radians. So sine is positive, and sine is positive in which 2 quadrants? So we're going to find some angle from quadrant 1 and also from quadrant 2. So sine is positive in both quadrants. What reference angle family are we talking about? We're looking for sine is 1/2. Well, that would be our 30 degree reference angle family. So 30 degrees into quadrant 1, and then 30 degrees into quadrant 2. Or pi over 6, our pi over 6 family, so pi over 6 into quadrant 1, and a reference angle of pi over 6 into quadrant 2. So the angles that we find in quadrant 1 would be pi over 6, and in quadrant 2, 5 pi over 6. Now if we're looking for all possible solutions, I'm going to take each of the angles that I found on the unit circle, and we're going to add multiples of 2 pi. Since we're talking about radians, a complete rotation all the way around the circle would be 2 pi. So we could say 2 pi times n. So integer multiples of 2 pi. And we'll take the second angle and do the same thing. Now these two angles are not equally spaced around the unit circle, so there's not a more concise or nice way to get from angle to angle. So this would be the most efficient way to describe all possible coterminal solutions for the 2 angles that we found.